All right, so I forgot about the homework. So let me see how this works anyway. Okay, good. Just like, all right, I think we're live. Okay, like I warned you, so watch what you say. All right, you have to open that up to take notes. All right, you too. Weird. Okay. Mhm. So I warned you yesterday about check digits, and the purpose of their use is we talked about a credit card, I believe. Ultimately, the most practical and where you would see it when you type it in the internet, and you get back, well, this is an invalid credit card. It's because you did an error. What were those two errors? One starts with a T. Come on, anyone? Transposing, which is doing what with the digits? Switching them. Dyslexia. I think everyone has a little form of that. I know I do it every once in a while. And then the other one is, quite frankly, just the single digit error. Instead of writing a 5 or typing a 5, you accidentally hit 4, which is right next to it. This is all, probably done by computer programmers, but it's all to check human error. And it's probably, systematically all over the place, not just credit cards. Anytime you have to type something in the internet, it's a system to check human error. And that's what we need to understand. So I don't know why this happens. Oh my gosh. All right. I guess it's not a big deal. All right. Now the first one, I do color code these because they're all different schemes. And as of right now, all you have to have memorized for this up to this point is not a social security number per se, but knowing that the first 3 digits of a social security number is what area you're from. And then, that's enough. And then a couple vocab words that I just went over. And then this scheme doesn't have to be memorized. Just pretend this is Company X, which their employees have to get an ID number or something. They have to pick an ID number. But their ID number has to fit this scheme only so that when the employee has to type their ID number in the computer, this is a system to make sure they didn't do an invalid one. So that, and I don't know. I'm just making that up. I didn't say that in any of the other hours. So this is company first one, whatever it may be called. Trying to get it there. There we go. Okay, so this is a real simplistic one. 4-digit ID is created such that the sum of all 4 digits is divisible by 8 using only 0 through 7. Now, that's not a coincidence, and I'll wait to probably cover that further. I lost my pen. Oh, I'm on lasso. I guess I could do this. Okay, these are tied together, and I'll wait till we do example 2 of this little scheme to kind of tell you why they usually do this. If it's a divisible by 8 scheme, then you really should only use 0 through 7 because of what the check digit should be. And the check digit's usually the 4th one, but in this case, it's just this is what it has to be. First things first, when someone types this in the internet, would this check a single digit error? Meaning if we replace one digit with the other, would it catch it? Yes or no? What do you think? Well, if I change a 6 to a 5, would that change the sum being divisible by 8? Yes or no? So yes. Would this check a transposing error? If it's 2, 3, 4, 5, I make it 3, 2, 4, 5. Would it catch that? Yes or no? No. Why? What's the sum still? Even though that one I just made up and the sum doesn't, but wouldn't the sum still be divisible by 8? So they ask you this. These are questions I ask you to think about as we do this, because I think they do ask you this in the notes. Sorry, they lose. Can't see some of these things on here. So this would not check or catch a transposing error. So it's not the greatest scheme in the world. All we're doing is just giving you a Mickey Mouse little introduction to schemes and what they might be. Your job is to read those schemes, analyze them, and then go ahead and use them. So 4 plus 6, isn't this 13? Correct? When you add these digits up, isn't that 13? Is that divisible by 8? Yes or no? No. So what would the computer say? This is an invalid worker number. You don't work here. Or you made a mistake. 5317. Hate when my hand hits this. There we go. It's the first time that happened all day. What's 5 plus 3 plus 1 plus 7? Isn't that 16? Is that divisible by 8? Yes or no? Are all these digits valid? Yes, yes, and yes. So this is valid, and you could proceed on with logging into the system, let's say. And then last but not least, 2932. First of all, why is this invalid in the first place? There's a 9, so it's invalid. Even though that adds up to 16, I believe, again, the system says you're not supposed to use 0 through, or only use 0 through 7. So silly. So just make sure we understand that. We're not going to do B just because overdone. Now, still purple, so it's still the same scheme. This scheme is not something that needs to be memorized. You know, if this was a test, the test would say the scheme is this. Now find D4 and D2 in this example. Okay, so the schemes are just randomly changed for no particular reason. So very simple. 7 plus 5 plus 3 plus D4. This is what you do. All right, just kind of throwing it out at you. You know, and I think you'll be able to handle it. Not note taker. We're in trouble. I do say this about that, and I see most of you taking notes. The reason we do that, you do know this, right? Right? It's not just because you have your own notes when you go home. You also activate your brain in a different way. You actually are more involved, whether you believe it or not. So I have seen people at a low percentage be successful as a non-note taker, but usually it doesn't work out. That's all I'm going to say about that. Okay, because you're not really activating yourself kind of passive in the notes. Okay, so what's 7 plus 5 plus 3? 15? I forgot this is my quiet class, right? Are you okay? You look sad. Am I bringing you down? All right. What would D4 have to be to fit this scheme of being divisible by 8? Very simple. D4 would have to be what? Some people whispered as if they were on their deathbed. 1. Because what's 15 plus 1? 16, and then 16 is divisible by 8. So the valid and only possible D4 could be 1. All right? So Mickey Mouse. Simple, basic, blah, 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 blah. Now I like this last one because it denotes why does it say in a divisible by 8 scheme we should only use digits 0 through 7. And it's because of this. 6 plus D2 plus 7 plus 3. You don't have to write that out. 16 plus D2. What would D2 have to be? 0. You do agree, though, it could also equal 8, right? Because if I stuck an 8 in there, then it would be a sum that's divisible by 8 still, correct? And that is why, for the most part, when they do a divisible by whatever scheme, the digits you should use are only 0 through 1 minus, or minus 1 of whatever you're dividing by, so that the numbers remain unique. Because otherwise, there'd be no difference between these two. And if someone put an 8 instead of a 0, then we don't have uniqueness. And it wouldn't catch a mistake, per se. So that is why usually that's the case, and I think we have something like that in our notes Monday. That kind of makes that decision. Nothing you have to worry about. I just talk out loud a lot about why would a divisible by 8 scheme only allow you to use 0 through 7. This is the reason. That is. Okay. Give you a second. I'll stop the movie for those taking good notes, which is most of you, and let you have a chance to do that. Okay, so here's a weighted check digit scheme. Why this? And does it really happen in the real world? I don't know. But let's see why you do a weighted as opposed to that last one, which was real basic. As you're writing this down, would this more than likely catch a single digit error? Would it? Instead of writing a 4, I write a 3 in a certain position. Would that change what the check digit should be? Yes or no? Wow, I'm not taping this class anymore. It sounds like I'm talking to myself. Is that a yes, everybody? We don't know? Well, of course it would. Okay. So I have 2195, and then whatever the check digit ends up becoming. The check digit has to follow this divided by 9 rule after this weighted sum. If I change this 1 in the second position to a 2, it jacks up what the check digit would be because we're still having a weighted sum or a sum that's divisible by 9. So darn tootin' it's going to do that. It will definitely mess that up. How about a transposing error? That one you should get spot on. Will this weighted scheme catch a transposing error, a switching of the two digits? Well, yeah, absolutely. Because when you switch the two digits, you switch who is getting multiplied by what when you're checking is the sum divisible by 9 after that. So when you have a weighted check digit scheme, it most certainly will check a transposing error now, and that would be the point of it. So again, this is a new company who tells their employees to get a 5-digit code or gives them a 5-digit code, and then it follows this scheme. The employee doesn't know any of this. The guy in charge of tech would be doing this and writing the programming so that when these employees type in their number to log in every day, it's valid. Something along those lines. I'm making up stuff, but it's kind of based in truth there. So who do I multiply 7 by? Come on, class, it's fun. 7 by what? This is awful. This is terrible. I'm making you to do this. This is on the internet. I'm already ripping on period 3 because they all look at me like I'm some sort of alien. I can tell some of you hate me. I already said it's day 3, and I've inspired hatred. It's a record. Actually, it's not. Probably hated me in day 1. 7 times what? Who do I multiply 7 by? Who is this first digit in this stinking thing that I'm checking? 2. There they are. They live. Plus, who gets multiplied by 2? 1. Who gets multiplied by 5? 9. I know what I'm doing next. Who's getting multiplied by 3? Isn't that fun? Don't you feel alive now? Plus D5. Okay? So what we need is to create D5 so that we have a number that's divisible by 9 in this weighted scheme. So all we do is do the weightings. 14 plus 2, I'll write them down. 14 plus 2 plus 45 plus 15 plus D5. And then go ahead and add these up. Oh, what did we get last hour? 76? What does that mean? D5 has to equal, sorry for my sloppy 5 there. What does that mean D5 has to equal? To follow this scheme of being divisible by 9. 5. Why 5? Well, why am I writing 5 so terribly? I don't know. 76 plus 5 is what? 81. 81 is divisible by 9 very evenly, so it's got to be that. So this person's ID number assigned by the tech master would have to be this, with the check digit being 5, so that it follows this scheme. Okay? If this person types in 29155, the computer program will analyze that as an error because it does not check in the weighted scheme that is involved here. Because 291 gives a different, that sum would no longer be divisible by 9 on that switch. Okay, here's the next one. Press pause. Okay, just a blabber. Get my voice on the thing there. New scheme, new company, different weights. You can see 3, 2, 1, 6, just for giggles. But also it's a different scheme where the remainder, when the weighted sum of the first 4 digits is divided by 5. That's actually the check digit. We already have to know a little bit about fractions all year long up till December. So you're about to get your first fraction lesson from me. That's not moving. Uh-oh. Okay. I'm having a problem. Computers. I think we're back. Okay. Not going to bother you. I already sense it. So 3 times 6, right? First digit. Yes, Mr. Stimulus. 2 times 5. Thanks, Danny. 1 times 3. You're welcome, Mr. Samuelus. 6 times 1. Oh my gosh. I had 3 people drop first hour, just so you know. All right, I stopped there. So D5 has nothing to do with the sum. D5 fumble. D5 is the remainder when the weighted sum is divided by 5. So we got to go ahead and find that. I think it's 37 from last hour. Did anyone do that ahead of time? Is it 37? Yeah. Okay, now we take this weighted sum and divide it by 5. And now here's your fractions 101. Drives me nuts how many students can't do this. How many times does 5 go into 35? 7. What is 7 times 5? 35. What's the remainder? 2. Now, I am going to do this. I'm going to write it like a mixed fraction so you understand it, because we're going to do this on Monday when we do what's called mod math, which is a different branch of math that's used in computer kind of stuff, but from reading on the internet and all that other stuff. But writing it as a mixed fraction, that's how you do it. 5 goes into 35 7 times with a remainder of 2, and you can put that remainder over what the divisor was. This is called a mixed fraction. But all we needed was the remainder, because the remainder is the check digit. So my code for this person is 65312. That remainder when the weighted sum was divided by 5. Now, why do that compared to the last one? I'm not sure which one's better, but the more complicated and convoluted the scheme is, the higher the percentage you're going to catch human error. The less complicated, like the very first one, transposing error isn't even caught. And then therefore you type in this number, the computer won't recognize it as a bad number. Okay, so let's move on. Doing, probably a little too over explanation. Don't have to write this down because I do put it in synopsis in the last page of the notes. But from your reading, how many people read? Let's not lie. How many people read up to 10 and maybe beyond? Well, you're ahead. Okay, and not that you understood it, at least you know the idea that there's a UPC code out there, and why it's done. Here is where you are going to have to memorize. I will not give you this scheme. I will just tell you on the next quiz, the UPC code is this, find the check digit. That's all you're getting. So I'm just throwing it out there, what your responsibility is and what you need to know. You do need to know that, and I'm sorry for the annoyance that I didn't get this to you ahead of time. Maybe on Monday, hopefully I can remember that anything that we're going to need for the quiz, I'll put it on a sheet of paper and give it to you now. So that when you're doing your homework, you don't have to flip through the book and find all these things on the pages. But I didn't do that yet. You're going to have to deal with that as of right now. But first number in the UPC code is the type of product. Second set of numbers is the manufacturer. You don't have these memorized, but you have to have memorized as though this is the manufacturer. Then you look it up on a chart. So you have to know first is type, second is manufacturer, third depends. Product number if it's not a weighted item. If it's a weighted item, it's the price. Okay, so you just kind of have to know that, but you don't have to have anything memorized as far as what the product is or blah, blah, blah. And then lo and behold, the last thing is the check digit. And what's a check digit? Well, we just talked about check digits. Anyone ever buy something from a butcher, like at Walmart, and get it weighed? What happens when they weigh it? What spits out and they slap it on the package? This thing. Okay, so it's still the same. First digit, 2, that you see right here is the manufacturer. I'm sorry, the type of item. The second is the manufacturer. The third number within it is actually the price. Okay, and that's put in a barcode. So that's the one little different UPC code. Okay, now you will have to look these up when you're doing your homework on your cheat sheet or whatever that I will supply for you on the quiz, which hopefully I'll give you Monday. These will be on there. Now let's be honest. This is Company X. You go to Walmart, these are all probably different. You go to Jewel, they probably have a different system. So just to give you the idea that this is Company X and other companies have different codes for different manufacturers, possibly. Maybe it is standardized throughout the industry, but I'm sure at this point, probably a little different than the book 2004. when this was done. So this is what you write down. Here's what a UPC code is, synopsis. It's a 12-digit number. That's what the D's mean. Digit 1, digit 2, digit 3 with the little subscripts. And broken down like this, just like, just wanted to show you that was in the book. You could have read this yourself. Type of product is digit 1. Manufacturer is the next 5 digits, 1, 2, 3, 4, 5. Yeah, D2 through D6. Third could be the product number or the weight or price dependent upon the weight. Then the magic word of the day, D12, is the check digit. Just to make sure that this is a valid number within this system. And then here's what you have to have memorized. The scheme. Again, just because. Gotta do something. It's really not hard. The scheme is 3 times the sum of the odd placed digits, not the odd digits, the digits in the odd positions. D1, D3, D5, D7, D9, D11, those added together. Plus just the even digits added together. 1 times that. So no weight on that one. And D12 makes the sum divisible by 10. So all of this has to be memorized. Said that 7 times now. So just giving you the information so you are clear. Stupid touchscreen. Okay. All right. So then silly little question about this, and then we're done. Okay, so here's it's a UPC code. 2 space 13276 blah blah blah. Find D12. Okay, now remember I told you about the homework, just like yesterday's worksheet. I told you just read the worksheet and then write your answers on a piece of paper. And you just read the question, and then your homework just has the answers. Same thing for this book assignment, but I think it would be smart to write your code down on your homework, because I know how it is when you look up, down, and you might lose positions, right? Well, here's what I mean. All right, so the weighted sum is 3 times the D1 position. Who's in the D1 position? Well, this is third hour. They don't answer, but what number is it, class? Come on. 2. Someone said 1 last hour. No, usually there's a space between the first and the second, but 2. Now, this is why we'd write this down. I would cross that off so I know, okay, I'm done with D1. This is why I would write it down. I'm just trying to help you out. Just that kind of guy. Plus, what would be the next one? 3, because it's in the D3 position. Cross it off so I don't lose my spot where I'm at, and I understand where these are located. I think you get it. Next one's 7. Next one is 0. Next one is 3. And then you better end up with this 1, because you know that's the 11th position, because you're looking and trying to find the 12th. And I think I wrote too large here, so I might have to now squeeze these in. Then the leftovers, that's D2, that's D4, that's D6, that's D8, that's D10, and I got to make D12 happen. I also got to fit it in here. I guess I could do this. All right. No, I'm still at the edge. Okay. Now, order of operations, say I add in here first before I multiply by 3. Don't distribute. That'd be silly. You only distribute if there's variables in there. That's so math 3 cat stuff. All right. 6, 7, 8, 9, 14. Is that 18? Yes, Mr. Samuelus. That's D12. I guess I could just erase that as people are catching up. Next thing, order of operations, say to multiply. 3 times 16, 48. Man, I cannot write D12 to save my life. Struggling. All right, and then what's 18 plus 40, 48, 58, 66? I got to do everything in here. All right, class. What's D12 got to equal? After all this, what's D12 got to equal? There's one and only one answer, 4. Okay, so the code, UPC code for this that would be valid is 21327605341 4. 4 is the check digit. Okay? All right. We are done.